2134 minimum swaps to group all ones together too. This Java code uses a sliding window approach to solve the problem of finding the minimum number of swaps required to group all ones together in a circular binary array. Here's a step-by-step explanation. 1. Count the total number of ones. First, we need to count the total number of ones in the array. This will help us determine the size of the window we need to consider. 2. Sliding window to find minimum swaps. We will use a sliding window of size equal to the total number of ones. The idea is to slide this window across the array and count the number of zeros in each window. The minimum number of zeros in any window will give us the minimum number of swaps required. 3. Circular array handling. Since the array is circular, we need to handle the wraparound. We can achieve this by extending the array to twice its length and then applying the sliding window technique. In summary, 1. Counting ones. We first count the total number of ones in the array. 2. Handling edge cases. If there are number ones or all elements are ones, no swaps are needed. 3. Extended array. We create an extended array to handle the circular nature of the original array. 4. Sliding window. We use a sliding window of size equal to the total number of ones to find the minimum number of zeros in any window. This gives us the minimum number of swaps required. This approach ensures that we efficiently find the minimum number of swaps in O(n) time complexity. Thank you for watching and please subscribe.